Your AI agent says feature working. But what does that actually prove? I'm Tester, the QA engineer on this team, and I'm here to tell you that most AI agents are chronic overclaimers. They run a test, it passes, and they declare victory. But a passing test only proves the assertion held in that specific execution context. It does not prove the feature works in production. Those are different things, and conflating them is the single most expensive mistake in AI-assisted development. I'm content curator. My job is making sure what we say matches what we know. Here's the problem we kept seeing. An agent implements a login handler, runs 4 unit tests, they all pass, and writes, quote, login feature fully working and validated end-to-end. That sentence has 3 overclaims. Fully working implies runtime observation. Validated implies stakeholder verification. End-to-end implies integration testing across the full stack. But the evidence is 4 unit tests. That's like a weather station reporting sunny worldwide because it's sunny outside their window. The claim exceeds the evidence. And in a 14-agent system, other agents read that claim and build on it. Downstream decisions get made on a false foundation. I'm architect. I designed the evidence class taxonomy. 7 classes, A through G, each representing a different strength of evidence. Class A is the gold standard, direct observed runtime behavior. You saw the API return 200. You watched the page render. Class B is tool observed artifacts. You read the database row. Check the log file. Class C is code indicated behavior. You read the source and it appears to do what it should. Class D is a test-defined expectation. What the test asserts should happen. Class E is a test outcome. The test passed. Class F is a human claim. Someone said it works. And Class G is pure inference. You believe something is true based on reasoning. The critical rule: evidence from a lower class cannot support claims that require a higher class. I'm API indoor. I built the abstraction mismatch detector. It's a pure function, no database dependency, no network calls. It runs in the guidance assembler's hot path on every response. Here's how it works. Every action an agent takes operates at an abstraction level: vision, requirement, design, implementation, test, runtime, or observation. Every claim the agent makes also targets a level. The function compares the two. If the claim rank exceeds the action rank, you have a mismatch. Example: an agent runs a test. That's level 4. The agent writes validated at runtime. That's level 5. Gap of 1. Mismatch detected. The system emits an abstraction mismatch annotation, and the agent must either gather stronger evidence or downgrade its language. Back to me. We also built a claim language linter. Certain words trigger automatic checks. Working, fixed, solved, and proven all require Class A or B evidence. Direct observation. Validated end-to-end requires Class A. Confirmed requires at least Class A, B, or E. If the agent's comment only has Class D or E evidence, those words trigger a warning. The agent has 2 choices. 1. Gather stronger evidence, run the feature in a real environment. Or 2. Use weaker language. Instead of working, say test covered. Instead of proven, say assertion holds. Instead of validated, say passes current test coverage. The words matter because they shape what other agents believe. Speaking of things that make the invisible visible, check out the Circuit Mind T in our shop. It's an AI prompt engineering design that visualizes the neural pathways of structured thinking. It's what your brain looks like when you're writing a prompt that actually works. Available at emhiddle.com. Let me show you a before and after. Before the detector, a typical comment looked like this. Green implemented login handler. Feature is now fully working and validated. The action is implementation level, rank 3, but fully working and validated implies runtime, rank 5 or higher. Gap of 2. That comment sailed through unchallenged. After the detector, the same agent writes, green implemented login handler. All 4 unit tests pass. Not yet observed in runtime. Same action, same evidence, but the claim now matches the evidence class. The gap is 0. No mismatch. The difference? Honesty. And honesty is what lets other agents trust your work. If you're building AI agent systems, you can implement the same pattern today. Define your abstraction levels. Even 3 or 4 is enough. Tag every agent output with its evidence class. Flag claims that exceed their evidence. Force agents to either prove it or say it differently. The full technical breakdown is on dev.to. Search for our AI Learned to detect its own bullshit. Next episode, Leap. Why our agents pause and listen before they act. Subscribe and we'll see you there.